In this class, I will explain another problem on computing the moment of inertia of a composite section. So it's a VTU model question problem. Determine the moment of inertia of the shaded area about the horizontal central axis as well as about the base AB. All the dimensions are in millimeters, centimeters. So this is the diagram given. If you observe the diagram, it is symmetrical about y-axis. If you can fix the y-axis like this, passing through the section, and x-axis I will take it as the bottom region. This becomes the origin. Now, if you take this as y-axis, you can observe that the given section is symmetrical with respect to y-axis. The given section is symmetrical with respect to y-axis. That means only we need to calculate y bar. So only y bar we have to calculate. That is the distance of the centroid from the x-axis, which may lie somewhere here. G may lie somewhere here. This distance, as you know, is y bar. You need not calculate x bar because it is not symmetrical with respect to x-axis. So the centroid lies on y-axis. The meaning of this is centroid G lies on y-axis. So only one distance we need to calculate, that is y bar. So you know that y bar is summation ai yi divided by summation ai. So here there are two simple sections here. One is the rectangle, the second one is the semicircle. So if you look at the centroid of the rectangle portion, it will be exactly at the center. So I will take this centroid, that rectangle as 1, semicircle as 2. So I will take this as your x-axis now. X-axis is the bottom end of the rectangle. You can see the distance from here to here is 25 divided by 2, which is 1.5 centimeters. Similarly, if you take the semicircle as the second area, and this area I can calculate later. The second portion is the semicircular lamina like this. So whose radius is given as 10 centimeters. So here, if you look at the centroid of this, so this is my x-axis now. If you look at the centroid of this, you know that the centroid of the semicircle, I will take this as d2 because this area, I am going to take it as 2. This d2 will lie at a distance of 4r by 3 pi. So 4r by 3 pi, which comes out to be 4 into 10 divided by 3 pi. If you simplify that, I think you will get that is 40 divided by 3 pi. 40 divided by 3 into pi. So it comes out to be 4.244. 4.244 centimeters. Now the distance from x-axis to this G2 is now this distance I need to note the centroid of the composite section. So this distance is nothing but now total is 25. 25 minus 4.244. 25 minus 4.244, which comes out to be 20.756. 20.756 centimeters. So these are the distances of the centroids of the semicircle and the rectangle portion from the x-axis. So now I can have a table, if you know how to draw the table. So serial number, figure, area, ai, which is in terms of centimeter square. Then I need yi in millimeters. Then product of ai and yi in millimeter cube. So these are the values I need. So if you choose the values, so one is a rectangle, two is a semicircle. Here you please note that semicircle is a cutout portion or a hole from the entire area, so that this area is negative. Area of semicircle is negative because it's a cutout portion, whereas area of complete rectangle is taken as positive. if you subtract the area of semicircle from the area of rectangle, you are going to get the area of this shaded region. So area of rectangle is now 20 into 25, which comes out to be 500 centimeter square. Then semicircle area, you know that it is pi r square by 2. For circle it is pi r square, for semicircle it is pi r square by 2. So minus pi into r is 10 here, so 10 square by 2. So the value you are going to get here, so 100 divided by 50, so 50 into pi, 50 into pi is the area which is 157.08, 157.08. Now that is negative, so if you add these two, you are going to get sigma ai yi. Add this here, you have to subtract here, so 500 minus 157.08 gives the value of sigma sigma ai, which is nothing but 342.92 centimeter square. That is the area A. Then distances of these two centroids are G1 and G2 from the x-axis. We have to write here. They are the values of yi. So for the first one, it is 1.5 centimeters. Please note that both the G1 and G2 they lie above x-axis. That means the distance is positive. So it is 1.5. Then for the second one, it is 20.756. 20.756. Now we have to take the product of these two. So if you take the product of those two, 500 into 12.5. 500 into 12.5 is 6250. 6250 millimeter cube. And for the second one, it is negative because area is negative. 157.08 multiplied by 20.756, which is minus 3260. 3260.35. Now we have to add this sigma ai yi. Whereas the second is negative, so we have to subtract. So 6250 minus 3260.35, which is 2989.61. 2989.61. Now we have to substitute these values. This is in centimeter cube. Now we have to substitute these values here to get the value of y bar. 2989.65 divided by sigma a is 342.92. So that is the value of y bar. So divided by 342.92, which is 8.718 centimeters. So this is the distance of the centroid of the composite section G from the x-axis. So this is y bar, which you have got 8.718 centimeters. Now this is the first part of the problem where we have located the centroid. So that now the second part is we have to find the moment of inertia of this shaded area about with respect to horizontal centroidal axis. Now horizontal centroidal axis means, so if you draw an axis passing through this G and parallel to this x-axis, that becomes the horizontal centroidal axis. So that means IGX. So to find MI about horizontal centroidal axis, of course for this we need to use parallaxis theorem. Horizontal centroidal axis, it is nothing but IGX. So you know how to use parallaxis theorem. I have done in the earlier problems also. If you have an area here, if you have the centroid here for this area, and if you draw a centroidal axis, for example, IGX is the centroidal axis. If you have another parallel axis to this axis, AB, separated by distance YC, and if this area is A, then if you know IGX, you can find out IAB using this parallaxis theorem. IAB is IGX plus A into YC square. This is the parallaxis theorem. So by knowing the moment of inertia about any axis, of an area about any axis, we can always find the moment of inertia of the area about some other axis which is parallel to the centroidal axis. So that means here in this case we have to write this expression for for both rectangle as well as semicircle. Now for the rectangle, I can write this as IGX of rectangle minus IGX of semicircle, because minus here because it is a cutout portion. So area is negative, moment of inertia is also negative. We have to note down that. Now IGX of rectangle I will write using this parallel axis theorem. Now I have to take this rectangle. So the distance of this, now I will write one more diagram so that you can easily understand. So this is semicircle portion, this is the rectangle portion. Now I need the respective distances of G1 and G2 from G. So that is what I need. So here, now I will locate this centroid here. G is here. So from this x-axis, this is of course the x-axis. So from this x-axis, this distance is y bar. We have found out that, which is 8.718 centimeters. This we have found out. And G1 I am going to locate. So G1 will get a distance of 12.5. You can see here from the x-axis. So it will be somewhere here. So G1 is here. So this distance is 12.5 centimeters. And G2 will get a distance of 20.756 from here. So this is G2. G2. So this is at a distance of, I can write 20.756. So that this distance will be that 4 by 4.244. So now using this diagram, we can find out this YC distances. So I will take the distance between G and G1 as YC1. So this is for the first one. I will take this distance as YC1 and I will take G to G2 as YC2. So from this diagram, let us calculate YC1 and YC2. YC1 is equal to, YC1 is equal to distance between G and G1, which is 12.5 minus 8.718. 12.5 minus 8.718, which is nothing but 12.5 minus 8.718 is 3.782. 3.782 centimeters. Now YC2, distance between G and G2, distance between G and G2 is, now this distance is 25 minus this 8.718, correct? 25 minus 8.718, so 16.28, so this distance is 16.282. So this distance minus this 4 by 3. So 16.282 minus 4.244. So that is the value of YC2, which is 16.282 minus 4.244 is 12.03 centimeters. So these are the values. Now A1 and A2 you know. A1 is the area of the rectangle, A2 is the area of the semicircle. Now only thing is we need to write down the moment of inertia of the semicircle and the rectangle above its centroidal axis. That means suppose if I take this as G1x and G2x, so we need the moment of inertia about those. Let me write that. So for rectangle now the equation becomes I G1x plus A1 into YC1 square. This is for the rectangle. Minus for the semicircle it is I G2x plus A2 into YC2 square. Okay. Now I G1x is the moment of inertia of the rectangle about its centroidal axis, which is BD cube by 12 for the rectangle. So for the rectangle, you know that B is 20, D is 25, this distance is 25. So 20 into 25 cube by 12. So Ig1x will be now 20 into 25 cube by 12 plus area of the rectangle. Area of the rectangle is 500. You can see here. Into YC1 3.782 square root. So this is the first part for the rectangle part minus For the semicircular part, so this is where you should be very careful. So you should know the expression for the moment of inertia of the semicircle about the centroidal axis. So that of course we have derived it. So better you remember the value. So now I will give the value. So that value you have to remember, otherwise you have to derive. That is the problem. Normally you will be knowing the moment of inertia about the diametral axis. About the diametral axis, it is pi r square, pi d square by 128. Okay, but about the centroidal axis, it is slightly different. So better you remember this value. So this Ig2x is nothing but, please note, Ig2x is nothing but the moment of inertia of the semicircle above its centroidal axis, that is Ig2x. So that expression you should know, you should remember. So that expression I will give you here. Better you remember this 0.00686 d power 4. D power 4 means diameter power 4. So this is the expression for the Ig2x. You can always replace the d by 2r and you can write in terms of r also. Plus A2 is the area of the semicircle, which is 157.08. So don't take minus here because already I have taken minus here outside the bracket, which says that if the area is negative, moment of inertia of that particular area is also negative. So 157.08 into yc2 square. yc2 is 12.038 square. So this is the expression. Now we have to simplify this. So we have to substitute for d now. So d here is diameter. Please note that r is 10. So therefore d is 20. It becomes 20 here. So this d we have to take 20 centimeters and we have to simplify that. Now let us try to simplify that. So your Igx will be now. So the first part will be now. I will just simplify that now. So 20 into 25 cube by 12. 20 into 25 cube divided by 12. This is this part plus 500 into 3.782 square. So this value you are going to get 33193. 33193.43. 33193.43, that is for this part. Minus second part is 0.00686 into 20 to the power 4, that is 400 into 400, right? Okay, plus 157.08 into 12.038 square. So the value now becomes 23860. 23860.6. 23860.6. So these two are the values now. So once again I will check. 20 into 25 cube for the rectangle divided by 12. So it is 20 into 25 cube divided by 12. So 26041. Sorry. This value is sorry, okay. I have to add that also. So plus, of course, 500 into 3.782 square, which is once again 500 20 into 25 cube divided by 12. This is one value, this value, plus 500 into 3.782 square, 33193. Okay, what I earlier written is correct. 33193.43 plus this value now, if I put D is equal to, D is diameter of the semicircle which is 20 centimeters, that I have to substitute. So 0.00686 into 20 to the power 4 means 20 square into 20 square, 400 into 400 plus 157.08 into 12.0 into 12.038 square. Okay, so this value is 23860.6. 23860.6. Now if you add and if you subtract this from this, you will get the MI of the composite section, that is shaded area. So what the answer is 33193.43 minus 23860.6. So the value is 9332.83. 9332.83 millimeter power 4. Centimeter power 4. So that is the unit. So this is the moment of inertia of the shaded area about its horizontal centroidal axis. Now he has asked about the base also. So to find the moment of inertia about the base, once again we need to use parallaxis theorem between the horizontal centroidal axis GX and the base AB. So now I will find that second part. So moment of inertia about the base AB. Moment of inertia about the base AB. So here, so we know that now what I will do here is, this is the semicircle. So you have G here and AB axis here. Now this becomes the centroidal axis. Now I know this value now. I know the value of IGX. I need to find the value of IAB using the same parallaxis theorem. So here the distance between these two is y bar. You know that distance is you have got 8.718 centimeters. Okay, and also area of this lamina is sigma ai, that is the area. You know that area is how much is that area? We got 500. So 500 is that area. A bit of 500 minus pi r square by 2. Pi into 100 divided by 2. So the area is 342.92. 342.92 centimeter square. This is centimeters. Now we have to use the parallaxis theorem to find this IAB. So IAB is equal to IGX plus A into YC square. So this is your YC. So IGX already we have calculated 9332.83 plus area is 342.92 into YC is the distance, that is y bar, 8.718 square of that. So if you simplify this, 9332.83 plus 342.92 into 8.718 square, so which comes out to be 35395.96 centimeter power 4. So this is the moment of inertia of the lamina, that is the shaded area, with respect to the base. So this is how we have to do. So I have used the parallaxis theorem twice, once for this thing, that is for finding the IGX of the composite section. Next, for transferring that IGX to IAB. So now here, the thing is here, suppose if they ask you to find the radius of gyration, so IGX will be square root of KGX will be square root of IGX by A, which is 9332.83 divided by A is 342.92. So that means the value is 9332.83 divided by 342.92, which is 27.22 centimeters. Suppose if they ask the moment radius of gyration about the axis AB, then you have to take square root of IAB by A. So the value will change. It is 35395.96 divided by 342.92. So here the value becomes 35395.96 divided by 342.92, which is 103.22. 103.22. So these are the values, but anyway in the examination they ask to know the any value, so you can stop at this stage. If they ask radius of gyration also, then you have to move further. So this is how you have to do a problem of composite section where the cutout portion is there, area is negative, moment of inertia of the cutout portion is also negative. That's why I have taken this problem. So from the total area we have to deduct the cutout portion. Area becomes negative, moment of inertia becomes negative, but use the respective formula. Here in this case, the only thing you have to remember here, this expression, because Ib2x is the moment of inertia of the semicircle about its centroidal axis, because normally we know about the diametral axis, so that value better you remember. So then you can transfer that to any other axis which is parallel to the centroidal axis.